One of the most beautiful human traits is our natural tendency to care for others. Throughout our lives, caregiving is more than just an instinct action. It's a fundamental process that brings us closer to others. Hi everyone, my name is Jiaxing. I'm a PhD candidate from Eindhoven University of Technology. Today, I'm excited to represent our team and share our research. Does care lead to bonds? Exploring the relationship between human caregiving for robots and human-robot bonding. Human-robot bonding has become an important topic in the HRI research field. Across domains such as education, therapy, healthcare, and everyday social interactions, fostering bonding with robots is often an essential design requirement for enhancing user acceptance and sustaining long-term engagement. Therefore, our research is motivated by the overarching question: how can we design human-robot interactions to foster human-robot bonding? Many existing studies have explored this question and generated valuable insights. These studies tell us that designing robots to be responsive, companionable, and empathetic are generally helpful to make people feel connected. These studies often follow an implicit assumption. That is, in order for humans to bond with robots, humans need to receive some care from robots to fulfill their social or emotional needs. However, However, receiving care is only one side of the bonding process. From attachment theory perspective, our earliest bonds as infants are indeed formed through receiving care. But as adults, our attachment is largely shaped by providing care. Similarly, many studies in friendship and romantic relationships have shown that caregiving not only helps recipients feel attached to the caregiver, but also help the caregiver feel attached to the recipients. All these insights suggest that bonding relies not only on receiving, but also providing care. This leads to our first research question. Does human caregiving for robots lead to human-robot bonding? Before answering this question, we also need to know what type of care can humans provide to robots. We identified two main kinds of caregiving in HRI context. One is instrumental caregiving, where humans provide technical or practical assistance to robots. The other is emotional caregiving, where humans provide comfort or reassurance to robots. Given these two kinds of caregiving, we ask, does the nature of caregiving, whether instrumental or emotional, affect bonds differently? We conducted a lab experiment to answer these questions. The experiment was contextualized within a game setting. In each round of the game, participants selected an object from a list, and then the robot tried to guess their choice by asking three questions one by one. After that, the robot made a guess, and the participant should tell the robot whether it was correct or not. In the first round, the robot always guessed correctly. In the second round, the robot guessed incorrectly but responded neutrally. In the third round, the robot failed again, and at this moment, the robot requested care from people. Participants were randomly assigned to one of the three caregiving conditions. In the instrumental caregiving condition, the robot expressed a need for power, saying, "I need more power to process information. Could you help by giving me a quick charge? Please move me to the charging station." In the emotional caregiving condition, the robot showed a crying face, saying, "I feel disappointed with my bad performance. Could you pat my head and say some encouraging words to me?" In the control condition, the robot did not ask for care. Instead, it initiated a system update by itself. After the caregiving interactions, the game continued, and the robot guessed correctly in the final round. Participants then complete a questionnaire on the computer. To measure bonding, we incorporated both explicit and implicit measures. On the one hand, following common HRI practices, we used explicit self-reporting measures, including the inclusion of other in the self, closeness, social attraction, and desire for future interaction. All these measures were directly adapted from human-human relationship literatures. On the other hand, we also measured bonding implicitly. At the very end of the questionnaire, we implemented a fake survey, stating that this survey is to have participant feedback on our lab facility upgrade. In this survey, we deceived our participant the Misty robot they had interacted with would soon be replaced by a new robot. And this leads to two implicit measures. First, reluctance to replace. We ask participants how much they mind that Misty will be replaced. Second, attraction of alternative. We ask participants to rate their perceived attractiveness of the new robot. And this measure was inspired by interdependence theory, which suggests that when people feel bonded with one person, they tend to devalue alternatives. And third, we also measured people's compliance as a sign of bonding. This was also inspired by interdependence theory, which suggests that bonds and compliance are closely correlated. To measure compliance, we let the robot request people to stay for a volunteer task after they have completed all the questionnaires. The robot stated that this task is very important to improve its algorithm and request people to complete as much as possible in this task. The task was designed to be boring and repetitive. Participants need to type 3 words to describe a picture. The picture will appear continuously, and participants are free to stop at any time by just closing the window. Here comes the results. First, manipulation check. In the instrumental caregiving condition, all participants charged the robot successfully. In the emotional caregiving condition, only one participant did not comfort the robot. The data was retained because removing it did not change the statistical significance of the results. In the control condition, no one provided any care for the robot. We did not find any significant differences across conditions in terms of explicit measures, including inclusion of other in the self, closeness, social attraction, and desire for future interactions. However, in implicit measures, we found significant differences between the emotional caregiving and control conditions. Participants who provided emotional care to the robot were significantly more reluctant to see it replaced. Those in the instrumental caregiving condition showed a similar trend, but the difference did not reach statistical significance. For compliance, participants who provided emotional care were significantly more likely to continue the volunteer task compared to the control condition. In summary, there are two major takeaways from our study. First, emotional caregiving is associated with increased bonding. While instrumental caregiving appears to show a similar pattern, the effect is not statistically significant. These results suggest that emotional caregiving can be an effective interaction design strategy to support human-robot bonding. Second, increased bonding was observed only in implicit measures, not in explicit self-reports. This raises two speculations. First, people's cognitive evaluation of their bonding with robots tend to be consciously constrained. Second, even if robots are perceived as social agents, they may still retain an underlying thinness which make the traditional human relationship measures not directly transferable to HR context. These considerations underscore the need for future research to critically conceptualize and operationalize human-robot relationships. We also have additional research questions and interesting findings. If you are interested, please check out our paper. Thanks for listening.